Hi, I'm Tony Chabz, practicing hydrologist for about 12 years. Today, I present to you the mechanical current meter and how it works. The basic parts of a current meter are: number one, the rod. The rod is 1 meter in length and has graduations. This can be attached to other rods depending on the depth of the river that is being monitored. Then we have the fish-like weight, which moves on the rod depending on the depth of the river, and this movable weight has a propeller behind it that rotates, and this propeller rotates depending on the velocity of the river. The faster the river, the faster the propeller. It's directly proportional. The number of revolutions a propeller makes in a second is denoted by the letter N, and this is from the equation V is equal to A plus B multiplied by N, and these constants A and B are the governing constants for a particular mechanical current meter. V in the equation stands for velocity. Assuming that a river is now subdivided into smaller areas, each of those areas will be multiplied by the individual velocity to get the discharge for that particular section. It is the sum of these individual discharges which is now obtained to get the flow rate, or rather the flow for a river at that particular section for that particular time. So one may ask, why do we have to go through this task to measure the discharge? Well, discharge measurements are important because, number one, water resources management. Discharge measurements help assess the availability and sustainability of water resources. It enables us to understand the amount of water entering and leaving a river system, which is crucial for planning and managing water supply for drinking, agriculture, industry, and ecosystems. Number two, flood forecasting and warning. By monitoring river discharge, we can anticipate and warn people of potential flooding events. High discharge rates indicate increased risk of flooding, allowing communities downstream to take necessary precautions and evacuate if needed. Number three, my personal favorite. I'm working for a hydropower company, as you know. So hydropower generation, discharge measurements are crucial for the efficient operation of hydropower plants. By knowing the flow rate of the river, power plant operators can optimize energy production and make informed decisions about water usage and reservoir management. Number four, environmental monitoring. River discharge data helps assess the health and ecological condition of a river and their surrounding ecosystems. It provides insight into water quality, sediment transport, and nutrient levels, aiding in the identification and management of pollution sources and the protection of aquatic habitats. And finally, number five, we can talk about engineering and infrastructure design. Discharge measurements are fundamental for the design of bridges, dams, culverts, and other hydraulic structures. By understanding the expected flow rates of rivers, engineers can ensure that infrastructure is adequately sized and can withstand the forces exerted by the water. Thank you for taking time to watch this video, and if you like this video, subscribe to my channel. Thank you. This is Tony Chabz, also known as the Digital Preacher. Bye-bye.